This is an example of angular momentum, okay, in figure first, which denote L is equal to R cross P. Okay, these all are vector quantities. Okay, so vector denotes here arrow. Okay, L denote angular momentum, R denote radial distance, P denote linear momentum. Okay, in figure first, you see here the ball which is rotating around, okay, in a circular way, and R is the radius, and P here is linear momentum, the direction of P, okay, here, which is equal to mass into velocity. Okay, so overall L is equal to mr square. In figure second, here angular momentum L vector, which is equal to I vector into omega vector. Okay, I here is moment of inertia and omega is angular velocity. Okay, so focus on this. We have studied in class 11 moment of inertia in detailed way. We know a circular object have radius and the cylindrical object have also length. Okay, solid cylinder or disk symmetry axis have moment of inertia half mr square. Hoop about symmetric axis mr square. Solid sphere 2 by 5 mr square. Rod about center 1 by 12 ml square. And solid cylinder central diameter half 1 by 4 mr square plus 1 by 12 ml square. Hoop about diameter I is equal to half mr square. Thin spherical cell 2 by 3 mr square. And rod about end, okay, moment of inertia is 1 by 3 ml square. What is moment of inertia? Okay, those is object dependent, where object is spherical, cylindrical, okay, rod and hoop about diameter. Okay, those all are example of moment of inertia. What is angular velocity, which is used in formula of angular momentum? W denote angular velocity, which is equal to theta upon time. Theta is position angle, T is time. And other formula of angular velocity is S upon RT. S is length of arc, R is radius of circle, T is time. And angular velocity is other third formula is B upon R. B is linear velocity, R is radius of circle. Okay, we can find angular velocity by using these formula which is given. So calculate by using that formula. If you like the video, then please subscribe our channel. Subscribe.